The map of the inner solar system is clean, organized, and familiar. But if you travel outward, past Neptune and Pluto, that neat planetary sequence dissolves into a sprawling, chaotic ring of icy debris known as the Kuiper belt. Out here in the dark, the standard definitions of planets and moons start to break down. This territory is filled with massive frozen anomalies that refuse to fit into easy categories. In 2004, astronomers at the Palomar Observatory in California located one of these massive entities, designated 120347 Salacia. It is an enormous object measuring over 838 kilometers across. You can't really see it, though. Salacia has an incredibly low albedo, or surface reflectivity. It reflects only about 4% of the light that hits it, making it a pitch-black ghost world drifting against the void. To understand the true scale and violent history of our solar system, we have to pinpoint exactly where this dark world lives and measure exactly how it behaves. Salacia orbits 42.2 astronomical units from the Sun, over 40 times further than Earth. A single year takes 274 Earth years. Viewed from the side, an anomaly appears. While major planets share a flat plane, Salacia is tilted at a severe 23.9-degree angle. This steep angle earns Salacia the classification of a hot Kuiper belt object. The term hot in orbital dynamics means its path is highly energized and erratic. It definitely didn't form at this steep incline. Billions of years ago, the massive blue sphere of Neptune plowed outward through the early solar system. Its intense gravity acted like a bulldozer, ripping through the primordial ice and violently scattering rocks into wild off-axis trajectories. Salacia's extreme tilted orbit remains exactly as Neptune left it, a permanent mapped record of the planetary reshuffling that organized our early solar system. Zooming in on Salacia's exact coordinates reveals another layer of complexity. In 2006, observations from the Hubble Space Telescope proved Salacia isn't traveling alone. It is a binary system, paired with a companion moon named Actaea. The two bodies share a uniquely tight spatial relationship. Actaea orbits Salacia across a gap of just 5,700 kilometers, making it one of the most compact binary systems ever mapped in the outer solar system. Under intense gravitational stress, the bodies pulled on each other for millions of years, a process called tidal evolution. This circularized their orbits and caused complete synchronization. Now tidally locked, they always show the exact same face, completing a unified cycle every 5.49 days. This perfectly locked relationship gives astronomers a flawless mechanical model. By observing their spin and distance, scientists can accurately calculate their exact mass and gravity from billions of miles away. Knowing their mass leaves one major analytical problem. Salacia absorbs 96% of all light that hits it. How do you map the physical composition of a rock you can barely see? In 2022, the James Webb Space Telescope aimed its near-infrared sensors at the Salacia system, penetrating its dark exterior to map the chemical spectrum underneath. Beneath that dark, neutral gray surface, the JWST sensors detected heavy concentrations of amorphous water ice, crystalline water ice, and frozen carbon dioxide. That heavy ice composition pairs closely with its high measured density of 1.5 grams per cubic centimeter. The math proves Salacia has the physical substance to be classified as a genuine dwarf planet candidate. It is a complex, dense world, hiding massive reserves of frozen water at the extreme edge of the sun's reach. Astronomers classify Salacia as a prominent water object, but what the James Webb Telescope didn't find is equally important. There is zero trace of highly volatile ices, like methane, anywhere on its surface. Volatiles easily evaporate and drive surface geology. The complete lack of them means Salacia has experienced zero recent geological activity. Its surface has remained frozen, static, and largely untouched. The map we've drawn is highly specific. Salacia is a dense, ice-rich dwarf planet, perfectly locked in a circular dance with its moon, while traveling on a steeply tilted orbit caused by ancient planetary migrations. Charting these dark, distant suburbs provides a geographical layout of space today, while preserving a pristine chronological record of the physical forces that built our home.